In this tutorial, we will be looking at polymorphism in C++. Like inheritance and composition, polymorphism is another fundamental concept in object-oriented programming. Basically, in polymorphism, you start with a vague description for a family of objects. From there, you can make the description more specific depending on the context or particular family member. This video is a follow-up to the previous video on inheritance in C++. It's important to be familiar with classes, objects, and inheritance before you proceed. It's also crucial to be familiar with pointers and memory allocation in C++. All the example code for this tutorial is available to copy and paste into your own project. You can find it by clicking on the link in the video description. Polymorphism comes from the word polymorph, which literally means a thing with many forms. In object-oriented programming, polymorphism is the ability of an abstract base class to take on multiple forms through its derived classes. An abstract class is a class that cannot be instantiated as itself. Instead, it serves as a base class from which more concrete classes inherit their attributes and behaviors. In our example, polygon is an abstract class. Therefore, we cannot create polygon objects. What we can do is create objects of its derived classes, triangle and quadrilateral. In C++, an abstract class has at least one virtual function. A virtual function is a method in a base class that must be overridden by its derived classes. We declare the virtual function with the keyword virtual and set the function to equal 0. Let's give the polygon class two virtual functions, getArea and getPerimeter. Note that we cannot determine the area or perimeter of a generic polygon since we don't know anything about its specific dimensions. It's impossible to measure the area and perimeter of a polygon unless we know the number of sides and each of its side lengths. Still, it's useful to include the area and perimeter methods as virtual functions in the base class since they describe essential components of any polygon. Basically, a polygon is a two-dimensional space enclosed within straight edges. The minimum number of edges is 3, so we can start implementing the virtual methods of polygon in triangle. We can find the area of any triangle by using Heron's formula. Let S equal 1/2 times each of the side lengths of the triangle. Then, we can compute the area as the square root of S times S minus side length A, S minus side length B, and S minus side length C. To get the perimeter, we simply add up the side lengths. For any cyclic quadrilateral, a quadrilateral that can be inscribed in a circle, we can compute the area by dividing the quadrilateral into two triangles, and then using Heron's formula to compute the area of each triangle. Finally, we add the areas of each triangle to get the total area of the quadrilateral. To get the perimeter, we simply add up the side lengths as we do in triangle. Now that we have an idea of how polymorphism works, it's time to start programming. In the video description, you can copy and paste everything you need for a working example. Just visit the link in the video description. You can see how abstract classes can be used to declare virtual functions, as well as create pointers to objects of derived classes. Thanks for watching.